In this video, we will learn how to find inverse of a matrix. But before learning about finding inverse of a matrix, let's learn that what is inverse of a matrix. So I will explain first in terms of numbers, and then I want to map the same concept on the matrices. Remember that this concept is not same, but it is similar. So let's say I have a number 5, and I multiply that number 5 with 1 over 5. Then obviously 5 and 1 over 5, they cancel each other, and my answer is going to be 1. So in this case, I can say that 1 over 5 is inverse of 5, right? Similarly, in case of matrices, if I have a matrix A and I multiply that matrix with a matrix B, and my answer is identity is like a 1 matrix, then I will say that A and B are inverse of each other. Matrices A and B are inverse of each other. But remember that B is not like 1 over A. So, but B is also a matrix, right? A and B are two matrices and they are inverse of each other. Now, important thing is that in general, matrices multiplication is not commutative. So that means in general, this is a multiplication sign, by the way, just a lazy way to write multiplication. So in general, matrix multiplication is not commutative. That means that in general, I cannot say that A times B is equals to B times A. So in general, this is not true. But in case of inverse matrices, the A and B are commutative. So if A and B are inverse of each other, then it doesn't matter that if you change the order of A and B, your answer will remain identity. So if A and B are inverse of each other, then in this case, A dot B is equals to B dot A. That means A and B are commutative, is equals to what? Identity. So let's continue. So if we have to say that find a matrix which is inverse of matrix A, we can simply say that find A inverse. That means this simply represents that find a matrix which is inverse of matrix A. So this -1 means that inverse, this symbol of inverse. And important thing is that not all the matrices are invertible. That means for some matrices we cannot find inverse, and we can in the future videos we will make matrices by ourselves which are not invertible. We will learn that. So not all matrices invertible. So but the matrices which are not invertible are called singular matrices. So the not invertible matrices are called singular matrices. That means if we cannot find inverse of a matrix because it doesn't exist, then it is called a singular matrix. And another important thing is that you can only find inverse of a square matrix. If a matrix is not square, then you cannot find inverse of that matrix. For example, if this matrix 1, 2, 3 and 0, -1 and 7 will not be invertible. It is a singular matrix because this matrix is not a square matrix, because in this matrix the rows and columns are not the same. In a square matrix, the rows and columns must be equal to each other. So not invertible. Yeah, maybe singular. or singular. So let's do some examples, because the best way to learn is by examples. So in this example, we have a matrix A given, and we are asked to find inverse of matrix A. Now let's see how can we find inverse of matrix A. So the method goes like this, that we basically write matrix A, we write matrix A and identity matrix side by side. So right here 3, 4, 0, 2, 1, 6, 1, 0, 5, and right here identity matrix. In identity matrix we have ones in the diagonal and rest of the entries are 0. So we have here 1, 1, 1, and here 0, 0, 0, 0, 0, and 0. And now we will apply elementary row operations. Remember what elementary row operations were? We have 3 operations. One was row swapping, second one was
row additioning
row,
and row multiplication.
Sorry, the three elementary row operations: row swapping, row multiplication, and row addition. We will apply those operations here, and our goal will be that at the end of those operations, those series of those operations, we have identity matrix here. And whatever operations we are applying in this matrix, we will also apply the same operation on this matrix. So at the end, we have here identity matrix, and we will have here inverse matrix. Now, why this method works is because we are basically adding all of those operations. We are basically making a matrix of all of those operations, which when apply on matrix A, then the result will be identity matrix. So we are recording all those operations here. Here we are recording all those operations, which when we apply on this matrix, then the result will be identity matrix. And in this side, we are basically converting this matrix into identity matrix. So now let's try to do this those operations one by one. So, and these operations are not unique. That means many people can use different set of operations, and they will at the end will get the same identity, same inverse matrix. So you can do different operations to achieve the same results. So first of all, we need a 1 here, right? So first of all, to make this identity, we need a 1 here. Now in order to get 1 here, what we can do?
We can row swap.
So yeah, so we have 2 methods. We can do 2 different things. One, we can swap this row and this row. So in this way we have a 1 here. Or we can also do one more thing, is that we can divide this whole row with
3.
You can divide this whole row with a 3. In that case, we also will have 1 here. But I will prefer the swap method, because in case of division, we will have the same result at the end, but we will have to deal with the fractions. So we want to avoid fractions because they make things complicated. Yeah. So first operation I'm going to do is R1 swap with R3. And I will also have to do the same swapping here, right? So now my result will be, so the first row going to be after swap is 1, 0, 5 and 0, 0, 1, and the second row will remain the same, which is 2, 1, 6 and 0, 1, 0, and the last row will be the first row, which will be equals to 3, 4, 0 and 1, 0, 0. So now we have here 1. Now what is our next goal should be? Because easy way is that our goal should be column by column. So our first goal was to have a 1 here. Now what is our next goal? We have to go column by column. So what we want here? We have 1. What we want next?
0.
So we want here 0. We want here
0.
0. Right? So next thing we always will going to do is that we multiply this row by 2 and subtract from here. In this way we will have 0 here. And for this what we will do?
Multiply it by 3 and divide it by...
Multiply by 3 and?
subtract it.
So we multiply this row by 3 and subtract from here. So the next two operations we have to do is, can you help me writing those operations?
R2 is equals to R1 multiply
R2
R2 multiply minus 2 R1.
2R. This is one operation, and the next operation, because I want to combine these two operations, these operations are independent. So next operation is going to be R3 is equals to R3 and what?
Minus 3R1.
Minus 3R1. So now we apply those operations here. So the first, because now we are changing second row and third row. So the first row we can just write as it is quickly and save our time. So 0, 0, 1. Now in the second row we have to multiply this row by 2 and then subtract from here. So 2 minus 2 is going to be 0, and 0 basically 1 minus 0 is going to be 1, and 6 minus 10 is going to be what? Minus 4. And these are 0, 0, so zeros, and this is like, because this one is 0, so this is going to be 1, and in this case what we'll have? We will have 0 minus 2, which is equals to minus 2, right? So if I make any mistakes, then it's your responsibility to find that mistake. Okay, so now help me with this one. In this one, I will say multiply this by 3. So 3 minus 3 is going to be 0. And then multiply this by 3, so which is minus 0. So 4 minus 0 is going to be 4. Then multiply this with 3, which is 15. So but minus, so 0 minus 15 is going to be? Minus 15. And this one remains the 1 because this is 0. And this remains 0 because it was 0. And now here we multiply it by 3. So 0 minus 3 is going to be? Minus 3. So now we are done with our first column. So basically we have to go column by column. We're done with our first column, and now we are going to go to the second column. In second column, our aim was to have 1 here for identity matrix, which we already have. If we doesn't have 1 here, then we have to do either two of the things. First, either we can swap these rows, or we can divide this with some number, this row with some number. But in this case, we already have 1, so we don't have to do anything. Second objective was for this column is what?
We have to get another 0.
We have to get 0 where?
And
Here.
in place of 4.
So 4. So how we can get 0 in place of 4?
Can we swap?
No.
We can multiply by 0.
No, multiply by 0 is not allowed. Remember? So any other suggestions?
We can multiply the second row with 4 and subtract it from the third row.
Yes, so we will multiply the second row by 4, so this will become 4, and then subtract from the third row, so this will become 0. So the next operation we're going to do, can you help me write that operation? The small one? Can you help me write that operation? It's going to be R3 is equals to what?
R3
R3 minus
2 R
2?
no.
We want to make it 0 here.
4. Yeah, 4 and 4 R2.
4 R2. Okay, so now we will achieve our this goal. So now we are going to write this. Once again, I'm quickly going to copy both of those rows to save my time. So because so 1, 0, 5, and then it's going to be 0, 0, 1, and then it's going to be 0, 1 minus 4, and this is going to be 0, 1 minus 2, and now I multiply this by 4, so when it will be 4, and then I will say 4 minus 4 is going to be 0, and I multiply this by 4, it will going to be what? Minus 16, and then I say minus 15 and plus 16, minus 15 plus 16, is going to be 1 here. Because I multiply this with 4, it is going to be minus 16. So I say minus 15 plus, so minus 15 minus minus 16. And this is going to be equals to minus 15 plus 16. So it's going to be minus 15 plus 16. That is going to be equals to 1.
Yeah.
So I have here 1. Similarly, in this case, I multiply it by 4, but doesn't make any difference. So it's going to be 1. And I multiply this by 4 and then say 0 minus 4. Answer going to be?
Minus 4.
Minus 4. Then multiply this by 4 and it's going to be like minus 8. So minus 3, and because I have to subtract it, so it's going to be plus 8. Minus 3 plus 8 is going to be what? Minus 3 plus 8?
Minus 3 plus 8 will be minus 6. 5.
5, right. So now we have 5. So now we have achieved our first column. We have to go, the rule is that we have to go column by column. We have done with the first column, we are done with the second column. And now we have to do the third column. In the third column, our aim is to achieve first here what? 0, here 0,
Yeah.
and here our aim is to achieve 1. Right? So now how can we achieve that aim? Any guesses?
We already have one, so we'll do what we did in row 2 and multiply that 1 with something and then minus it.
Yeah,
With other two
very
ones.
good. So what we're going to do is that we say R2, because we want here 0,
Yeah.
and we are going to use this row because we already have 1 here, and we cannot use above row to make 0 here, because if we use this row to make 0 here, then the 1 or something else will come here. So in this case, we can use the last row, because the last row will only change at this last entry, right?
Yeah.
So now we're going to use this last row to make 0 here and 0 here. Now write me those two operations. R2 is going to be
R2 minus,
it already have minus sign,
so plus
plus
4
very good, 4
R3.
R3. And for this one, R1 is going to be what?
R1, so
R1
minus
minus
5
5
R3.
minus 5 R3. So we can quickly write the first row, because we okay, we cannot write the first row because changing the first row. We can quickly write the last row, the third row, because we're not changing the last row. 0 0 1, and here we write 1 minus 4 and 5, and here we will write what? Now we multiply this row with 4 and then add here. So that means that we have here 0, and 0 times 4 doesn't make any difference, so 1 will remain here. Now we multiply this by 4, it will become 4, and then it will become 0. Now multiply this by 4, and then we add here, it will become 4. Multiply this by 4, it will become like minus 16. We add minus 16 in 1, so minus 16 plus 1 is going to be?
Minus 16 plus 1 is going to be minus 15.
So minus 15, so going to be minus 15, and then we multiply this by 4, it will become what?
20.
20, and plus 20 basically, because if we have plus, so it's like 20 minus 2 is going to be what?
18.
Minus 20 minus 2 is going to be 18. So this is, we are done with our last two rows. Now we have to do that only one more row, and then we have inverse. So in this case, because we have 0 here, we can simply write 1 here. We have 0 here, we can simply write the same 0 here. Now this we multiply by 5, and then we subtract. So say 5 minus 5 is going to be 0. We multiply this by 5, and then we say 0 minus 5 is going to be what?
0 minus 5 minus 5.
Minus 5, and then we multiply this by 5, right? It will become like minus 5, and it will become like minus 20 plus 20. So it's going to be here what? It's like 0 plus 20 is going to be what? 20. We multiply this by minus 5, so it's going to be minus 25. So 1 minus 25 is going to be?
1 minus 25 is going to be minus 24.
It's minus 24. And that's our matrix B, and B is basically inverse of matrix A, right? But we have to do 2 more examples, and for that you guys are going to help me out. So let's start.
No.
We are very excited. Yes!